welcome to the Deep Dive. Today we're plunging into some pretty major tech news, a bombshell really that's shaken up the semiconductor world.
It really has.
We're talking about Intel and Nvidia, traditionally fierce competitors, now announcing a truly surprising strategic alliance.
Yeah, surprising is definitely the word.
And the market reaction. Intel's stock shot up over 30% in pre-market trading just on the news. I mean, that tells you something.
It tells you a lot. That kind of shift would have been unthinkable just a few years back.
So what's the core of it? Nvidia's putting in a hefty $5 billion investment in Intel, buying shares at $23.28.
Right, but it's more than just cash, isn't it? They've also signed a joint development deal, new chips.
Exactly, and not just minor tweaks. They're aiming big PCs and data centers, especially for AI.
Which is, where everything's headed.
Absolutely. So our mission today is to really unpack what this means for Intel, for Nvidia, for the whole semiconductor landscape.
And for you, listening in, how does this actually affect the tech you use or watch develop?
Precisely. This isn't just some corporate deal-making headlines. It feels like it could reshape power dynamics, maybe even the future direction of chips. So let's get into the nuts and bolts.
Okay, so starting with the money. That $5 billion from Nvidia, it's actually part of a bigger picture for Intel.
Right. There were other recent investments, too.
Yeah, the U.S. government put in money earlier at around $20.47 a share, and SoftBank, too, back in August at $23.
So all told, how much new capital are we talking about for Intel?
Roughly $16 billion, which for a company like Intel right now, undertaking these huge multi-year projects.
Upgrading their manufacturing, the process tech, packaging.
Exactly. It's basically a lifeline. It lets them fund that really ambitious stuff without drowning in debt. It's a huge vote of confidence, really.
Okay, so the money's critical. But you said it's more than that. The joint development part. Two main product areas.
That's right. First, for AI infrastructure, Intel is going to design custom by 86 processors, specifically for NVIDIA's AI systems.
Okay, by 86, the standard architecture for most PCs and servers. But why does NVIDIA need Intel to make a custom version for them? They have their own chip expertise.
It's a good question. The idea is that these custom chips can slash bottlenecks. The communication hurdles between the CPU and NVIDIA's powerful GPUs.
So the GPU is the engine, but it needs the CPU to manage things, and sometimes that connection slows it all down.
Precisely. So a custom Intel by 86 chip designed just for NVIDIA's setup could make that data flow much smoother, maximize the performance of those big AI clusters, keep them ahead.
Squeezing out every last drop of performance. Makes sense.
And the second product area, consumer PCs.
Yeah, this one sounds really interesting, too. They're calling it an by86 RTX SoC.
Let's break that down. By 86 CPU, RTX is NVIDIA's gaming graphics, and SoC is system on a chip, all integrated.
Exactly. Intel CPU cores, NVIDIA RTX GPU tech, all on one piece of silicon. Think about thin and light gaming laptops.
Which always struggle with heat and battery life when you try to cram in powerful graphics. Right, that's the target. This SoC aims to solve those power and thermal challenges by integrating everything really tightly. The hope is high-performance gaming and much slimmer designs.
Okay, this sounds promising.
Okay.
And underpinning both of these, the AI chips and the consumer SoCs, is this thing called NVLink.
Yes, NVLink. That's NVIDIA's proprietary interconnect technology. It's how the custom Intel CPU and the NVIDIA GPU will talk to each other in both these new products.
Most people know PCIe is the standard connection. Why NVLink? What's the big deal?
Well, PCIe is fine for general stuff, but it can be a bottleneck, especially for AI or high-end gaming. Think of it like PCIe is a good highway, maybe a few lanes.
Okay.
NVLink is more like a dedicated high-speed bullet train line built specifically for the CPU and GPU. Much higher bandwidth, much lower latency.
So faster data transfer, less waiting around.
Exactly. That tighter coupling is the core bet here for both companies. They think it unlocks performance that you just can't get with standard PCIe setups.
Got it. Now, here's a detail that really jumped out. NVIDIA didn't commit to having Intel actually manufacture these chips, did they?
No, they absolutely did not, and that's a really important detail, a sort of reservation clause, if you will.
What does that tell us?
It tells us that while NVIDIA is happy to partner on design, they're still, shall we say, cautious about Intel's manufacturing capabilities right now.
Intel's still got to prove itself with those new process nodes like 18A.
Precisely. They need to show consistent yields, performance, the whole package, before NVIDIA commits its valuable designs to Intel's factories or foundries. Manufacturing is deliberately left open.
That speaks volumes. Okay, so let's shift to the strategy, the why behind it all. What's in it for NVIDIA? That $5 billion is what, maybe 2% of their market cap? Seems small for them?
It is relatively small for them, yeah. But look what they get. Custom by 86 chips for their key markets, AI and PCs, without the massive risk or cost of developing it all themselves or building their own fabs.
So it expands their options without huge upfront investment.
Exactly. Plus, that by 86 RTX SoC lets them push into markets like those thin gaming laptops where their discrete GPUs face limitations before. It's about extending their reach. Smart move.
Okay, that makes sense for Nvidia. Low risk, high potential reward, broader reach.
Yeah.
Now, flip side, what's Intel's logic here? Obviously, the cash is huge.
The cash is vital, no question, but it's also about validation. Getting a stamp of approval from Nvidia, the current industry leader, that's massive.
A signal to the market and maybe to Washington, too.
Definitely. It lets Intel leverage its history of customizing Xeon server chips for big clients, now doing it for Nvidia. It says, hey, even while we're rebuilding manufacturing, we're still central to cutting-edge design, packaging, interconnect.
Teach-outs, we're still relevant at the highest level.
Exactly that. It's a powerful message.
Now, this kind of deal sends ripples everywhere. Who feels the heat most? I'm thinking AMD.
Oh, absolutely. AMD is probably looking at this from two angles. Double pressure.
Us.
Well, in the data center, this new Intel-NVIDIA NVLink combo strengthens NVIDIA's hand considerably. It might chip away at the advantage AMD was building with its own integrated CPU-GPU platforms, like the Instinct line.
Offering a potentially tighter, faster alternative.
Right. And then there's the PC side.
The gaming laptops. AMD's done well there with their APUs, combining CPU and decent graphics.
They have. But this by 86 RTX SoC looks like a direct challenge to that foothold. NVIDIA, now partnered with Intel's CPU muscle and using NVLink, that could be a very compelling alternative in that lucrative market.
So pressure on both fronts for AMD.
Hmm.
What about TSMC, the big manufacturer in Taiwan? Any threat to them?
Not immediately. TSMC is still the king of advanced manufacturing, but long-term, it's something to watch.
How so?
If, and it's a big if, Intel really nails its upcoming process nodes like 18A and their packaging tech, if they become truly competitive on yield and cost.
Then maybe, just maybe, some NVIDIA business could shift to Intel's foundries eventually.
Potentially. It remains hypothetical for now. TSMC is way out front, and NVIDIA hasn't committed anything on manufacturing. But it's a long-term possibility Intel is surely aiming for.
Now, we've seen attempts to blend rival tech before. I remember Intel's Kaby Lake G back in 2017, Intel CPU, AMD Radeon graphics on one package.
Ah, yes, Kaby Lake G. A bold experiment.
But it didn't really take off, did it? It sort of fizzled out. Why?
It did fizzle. There were several issues. Driver updates were messy. Who was responsible wasn't always clear. Integration wasn't seamless. The product line just got canceled. Good idea, maybe, but the execution stumbled.
So why might this Intel-NVIDIA effort be different? What makes it more likely to succeed where Kaby Lake G failed?
A few key things. First, NVIDIA keeps control of the GPU drivers. That's critical for performance and stability, and it was a pain point before.
Okay, clear responsibility there. What else?
The interconnect. NVLink versus PCIe. As we said, NVLink is fundamentally tighter, lower latency. It's not just sticking two chips next to each other, it's designing them to communicate deeply.
A true architectural integration, not just putting components together.
Exactly. The architecture, the incentives, the control, it all seems much clearer and more robust this time around.
Interesting. Okay, let's talk geopolitics for a moment. The U.S. government has that 9.9% stake in Intel. They clearly have an interest. What's the angle there?
Well, yeah, the government isn't just a passive investor. They want strong, domestic, cutting-edge computing. Intel is key to that strategy, especially given global supply chain concerns.
So this partnership helps strengthen a key U.S. player.
It does. It bolsters Intel, aligns with that goal. And for NVIDIA, it provides options while potentially strengthening the domestic ecosystem. It's a rare case where, national strategy and corporate strategy seem to align quite nicely.
But it's not all smooth sailing. Execution is everything, right? Especially with something this complex. What are the big risks?
Oh, the risks are huge. This kind of tight CPU-GPU coupling is incredibly difficult to get right.
What kinds of challenges?
You need custom silicon working perfectly together. Unified memory, making sure the CPU and GPU see and use memory the same way. Coordinated firmware. And just managing the heat, especially in laptops.
You've seen attempts at desktop performance in laptops fail because of heat or drivers or bandwidth limits before?
Exactly. Those are the classic pitfalls, making these integrated systems work flawlessly, reliably, and affordably at scale. It's a monumental engineering task. Really, really tough.
And complicating things. Nvidia has its own CPU plans, right? The ARM-based Grace CPUs. How does the Intel deal fit with that?
Good point. Nvidia isn't putting all its eggs in the Intel basket. Grace is ARM-based, aimed at specific high-performance computing, AI workloads where things like memory bandwidth are paramount.
Usually in big data centers.
Right. So the Intel Die-86 partnership is more like a complementary track. It's a branch option, you could say.
For markets where the existing x86 software and ecosystem are just too dominant to ignore.
Precisely. It lets NVIDIA play strongly in both major CPU architectures, covering all the bases depending on the customer and the market. Hedging their bets, essentially.
Which brings us back to that manufacturing question.
Sure.
It's still just hanging there, isn't it? Deliberately left blank.
Very much so. It's the elephant in the room, maybe. Whether Intel Foundry actually makes these custom chips for NVIDIA, that's not just about strategy.
It depends on results,
Yeah.
timing, yields, cost.
Exactly. Intel has to deliver the goods on their manufacturing roadmap. This deal validates their design side, but the foundry win. That still needs to be earned through proven execution. We won't know until we see launch dates and performance data.
So zooming out one last time, what's the big overarching trend this deal highlights? Is it just about these two companies?
I think it's much bigger than that. It really signals a permanent shift. We're moving away decisively from the era of the general-purpose CPU being the undisputed center of the computing universe, towards tightly integrated accelerator-first systems, think GPUs, AI accelerators as the primary engines, with CPUs playing a crucial but perhaps more supportive, customized role.
And the value shifts too.
Absolutely. Value is consolidating around companies that control the whole stack, the silicon, the interconnects like NVLink, the software, the whole system design. It's less about mix and match components now.
And in this new world order, where does Nvidia sit?
NVIDIA is pretty clearly at the top of that pyramid right now. This deal kind of formalizes it. Even Intel, the former undisputed champ, now needs NVIDIA's ecosystem, specifically NVLink, to compete effectively in key AI markets.
It really shows Nvidia's power.
It's a stark illustration, yeah.
So for customers, for you listening, what are the upsides and downsides of this shift?
The upside, the promise, is better performance. More compute power per dollar, per watt, per rack space, less inefficiency from connecting separate parts, faster AI, better gaming.
Sounds good. The
Yeah.
downside?
Lock-in. NVLink isn't an open standard. Once you invest heavily in this tightly integrated NVIDIA-centric stack, whether it's with Intel CPUs or others,
Switching to something else becomes really difficult and expensive.
very much so. It's the classic trade-off. Potentially higher performance versus vendor flexibility.
A really important trade-off. Okay, so let's recap this deep dive. Key takeaways. Nvidia is cemented as arguably the king of the current semiconductor hill. Even Intel is now partnering within its ecosystem.
Right. And the bigger trend, a permanent move towards these tightly coupled accelerator-focused systems, away from general PCIe-based designs with things like NVLink becoming central.
It really is a foundational shift,
It will shape computing for years to come.
which leaves a final thought for you, our listener, to mull over. If giants like Intel are adapting and aligning within this new hierarchy, what does that signal for future innovation, for competition? And ultimately, how will this fundamental reshaping of the chip world impact the technology you rely on every single day? Think about that. We'll see you next time for another Deep Dive.